Hello everyone. In this video, let us take a look at what are the components of Ethereum and understand how these components come together to make up the functionality of Ethereum.
Let us start by understanding what are accounts in Ethereum. Accounts in any blockchain, in fact, are your entry into the blockchain, or rather your identity on the blockchain. In an account that you create on top of a blockchain network is where you store the tokens or the cryptocurrency of that particular network. Using your accounts is how you can perform transactions over the blockchains. So let's see what are accounts in Ethereum. There are two types of accounts in Ethereum that share the same address space. The first one is known as externally owned accounts, or EOAs, that are controlled by the public private key pair. So, your externally owned accounts are nothing but accounts that you create to store some ether, right, as a part of your wallet. Your contract accounts are controlled by the code, that is your smart contract code, which are also stored together with your externally owned accounts. So the two types of accounts that can be created on your Ethereum blockchain are externally owned accounts and contract accounts. Contract accounts are those accounts from where you deploy your smart contracts onto the blockchain. And your externally owned accounts are those accounts where you store your ether, right? Let us see the different types of transactions that can happen between the externally owned accounts and the contract accounts, right? Now, as you see in the first set of transactions, your externally owned account can call or perform a transaction to the contract account, which in turn can internally call another contract account. So here you can see that there are two types of transactions that are happening. That is an externally owned account calling a contract account, as well as a contract account calling another contract account internally, right? So this could be, your first one could be you deploying a contract, right? That could be one way. Or you could be sending certain ethers to a particular contract, or you could be using your account to call a contract that is on the blockchain network. Now that contract that you have called may internally have some calls to call another contract, right? And this is the second type of transaction that you see here. Another type of transaction that you see is externally owned accounts calling other externally owned accounts. So you could transfer ethers between two externally owned accounts, which are just like transferring money between any two accounts, right? The analogy for that on the Ethereum blockchain network. We'll see a little more about the accounts in a couple of minutes, but here is how you can use your accounts to perform transactions. Sorry, we'll see more about transactions in a couple of minutes, but here is how you can use the accounts to perform transactions on the blockchain network. Now, the second and of course an interesting feature, right, of Ethereum network are the smart contracts. So if you see the definition of Ethereum, or if you go to ethereum.org and see what they say about Ethereum, is that Ethereum is the first programmable blockchain, and that's true, right? So the programs or the piece of code that is stored on the blockchain is known as a smart contract, right? So a smart contract is nothing but think of your agreements, right? That you sign in a real time scenario. An agreement between you and your owner if you're staying in a rented house. An agreement between you if you are a lender and there is a borrower who's borrowing some money from you. An agreement between you as a lender and your borrower, right? Stating certain terms and conditions based on which certain actions will be executed once a particular deadline reaches. So, an analogy to the smart contracts, that is the programmable entity on the blockchain, is your real world agreements, right? So, if we come back to the smart contracts, that is your blockchain agreements, it is a piece of code which contains some logic which has all these rules and conditions that you will put in the form of code and then deploy it on the blockchain and this particular piece of code gets executed on the blockchain, and some actions happen based on the conditions that you have written on the code. So let's see some features of the smart contract. What is a smart contract on Ethereum, right? Smart contracts are nothing but similar to your computer programs that comprise of the business logic for your applications. For example, if you want to build an application where a voter's identity can be verified, right? If you want to build a decentralized application where a voter's identity can be verified, you can write a smart contract wherein if a particular voter, say, uploads a picture where the picture of the voter matches the picture that they take using your camera feature, then the voter is registered automatically. So based on some condition, you are performing some action, right? Or if you want to build a decentralized app, for example, for an education based system, right, where if a student gets particular amount of marks, then the student is automatically marked as pass, and they get the certificate to go to the next term, right? So I'm just giving some example of logic that you could put in your smart contract. It could be anything based on the use case or the application that you are building. Once a smart contract is deployed on the blockchain, we cannot change any information on the smart contract and it remains immutable. So, if you remember a couple of minutes ago when I showed you the demo on the Anders Brownworth website, there I showed you that once data is logged or a block is mined and added to the blockchain, the data is encrypted or it is safeguarded using a cryptographic hash, right? So the similar concept applies to a smart contract. The smart contract code actually becomes the data eventually in some format and is cryptographically secured using hashes. So once you write a logic in the form of a smart contract and deploy it on the blockchain, you cannot change anything on this smart contract. This is one of the drawbacks, we can say, of smart contracts in Ethereum. But this is also important because when you are doing any financial agreements or when you are doing any financial transactions which require some terms and conditions, you want to ensure that those agreements, those terms and conditions cannot be tampered with easily. And this is where blockchain can be very, very useful. One of the other takeaways from this property is that whenever you write a smart contract, you need to be, in fact, very, very smart and build in logic in such a way that you don't have to change it later. You can, of course, by the way, deploy another smart contract and refer to this smart contract and make the changes in the new one, but it's a cumbersome process, right? Yeah, the next point is the same. The only way to change a smart contract is to redeploy a new one on the network. And you need to reference it to the old one, saying the old one is not valid anymore. Smart contracts operate with very limited execution context. So let me explain to you what is very limited execution context. So smart contracts, so if you think about blockchain, right? You think about blockchain being a huge chain with a lot of transactions and a lot of information about all of these transactions that have happened in the past since the genesis block of that particular network, right? Imagine your Ethereum blockchain network. There must be billions and billions of transactions that have happened on that network. So there's a lot of information that is present in the ledger. But smart contracts, as such, they do not work with all of these blocks that are a part of the blockchain, right? By default, they operate with a limited execution context so that they can focus on what they are meant to do, right? They can access their own state, the context in which the transaction has been happening, or the different transactions that are happening, the context of those that is related to that smart contract, and some information about the most recent blocks is what you can access, or you should preferably access from your smart contract. So now let's move to the interesting part of the interesting feature of Ethereum, that is the transaction, right? So how do transactions happen? What are the different transactions that are present in the Ethereum blockchain? Well, you've already seen a glimpse of it when I spoke about the accounts. But here are the three types of transactions that can happen on the Ethereum blockchain. The first is transferring Ether from one account to another. Now, if I were to quiz you, what kind of accounts were these? I hope all of you said externally owned accounts, right? So we can transfer Ether from one externally owned account to another externally owned account, right? As I go through these transactions, I would also like to show you examples on the browser. So if you see this particular transaction, right, you can also go to etherscan.io and look at the different transactions. As I said, blockchain is nothing but a distributed ledger, right, where all the transactions, especially for public blockchain, is available to view by the public, right? So if you see here, there is a transaction that has happened on Jan 10th, 2021, right? And this transaction is from a particular account address, wallet ID, and it is to another address, right? So these are public addresses. I said that externally owned accounts are characterized by two addresses. One is public address and one is private address or private key, public key and private key, a key pair, right? Your public key is your address which is available to the public, so you can transact using that address. Your private key is used to sign the underlying transaction. So you should, whenever you create an account, you will be generate a public private key pair will be generated for you. Your public key will become your address, and your private key, you should keep it always safe. So when you create an Ethereum account or any other account, you'll get a 12-word mnemonic, right? And that mnemonic is what is associated with your private key. So here you see there are two addresses, from an address to an address. 0.09 ethers have been transferred, right? So this is one type of transaction. So the value of this ether at present today, that is while I'm shooting this video, is $118.06, right? 0.09 ethers cost this much dollars. So this address has transferred to this address these many ethers. So this is one type of transaction. You can see some other parameters associated with the transaction, such as transaction fee, right? So there is a transaction fee that is associated, that needs to be paid for doing the work, right, for this particular transaction. There is a block ID, as we have seen. There is a timestamp, when did the transaction happen, from address to address, the status of the transaction. There is a transaction hash that is generated for every transaction. There is a gas price and a gas limit, which I will talk about in just a minute, or just a couple of minutes. How much gas is used by the transaction, right? The nonce, and some input data if there is any data associated with it. But since this is just a cryptocurrency transaction, right? One wallet, one address transfers some amount to another address. So there is no input data. When there is a smart contract call happening here, there might be some input data, right? So going back to the next type of transaction. If you see the next type of transaction, it is a transaction that is deploying a smart contract, right? That is, from an externally owned account, you can deploy a smart contract, right? One type of transaction. So uh, let me show you an online editor called Remix Editor, right? And this is a small smart contract. This is also something that I wanted to show you as I explained about smart contracts themselves, right? So if you see, this is it written in a language called Solidity, the version being anything greater than 7 and less than 8, between 7 to 8, right? So as we speak, this is the version of Solidity that has been released. This is the name of the smart contract. So we will go into detail about smart contracts and how to write them in the hands-on workshop session. But here I just wanted to show you that when you deploy a smart contract, so here as a part of the Remix editor, you get some dummy accounts created for you, so you can test it. Remix editor is used for, it's free, and it's used for testing your smart contracts, right? So here is the account, here is an account, say let's choose this second account that has been generated for you, right? These are dummy accounts and it has 100 dummy ethers, right? Now I've already compiled the smart contract, so it is ready to deploy. Once you deploy the smart contract, that is a transaction, which is what I wanted to show you. Let me expand this here so we'll see the transaction. I deploy this, right? And I'll just expand this. So you can see that the transaction status is true, right? Transaction mined and execution succeeded. There is a transaction hash that has been generated. A contract address gets generated for every contract. We'll talk about this in a little bit more detail in the workshop session. But you can see from the particular account that I chose, AB8, right? This particular transaction has been initiated to deploy a smart contract. And what is it to? So if you see the to, it is this smart contract, that is storage, name of the smart contract dot constructor. So the constructor, that is the default constructor of this smart contract, has been called. So from address is the address from where you are, the externally owned account from where you are deploying, and the to address is your smart contract, right? And then there is some gas fee associated with it. There is a transaction cost for performing this transaction and an execution cost, right? So yeah, and so on. Now let's go back. The third type of transaction is transferring Ether from an externally owned account to a contract. So for this, let's go to Etherscan again and see an example, right? Mm, Let me show you. Yeah, okay. So what does this mean is that if you have a contract, sometimes you have contracts where you need to send ethers, right? Because the contract is written in such a way that maybe it is a gaming contract, right? Where you need to send some ether in order to continue playing that game. Or maybe it is a contract where it is, for example, if you know a freelancer.com, right? If you think of a decentralized freelancer.com, so you need, as a freelancer, maybe you need to send some tokens to that contract to, block your position for a particular job, or your job poster, whoever's posted the job, send some ether to the contract, so which can be paid to the person, to the freelancer, right? So these kind of transactions can happen to and fro to a contract, right? That means from an externally owned account, you can send some ethers to a particular contract. That is one another type of transaction. So here you can see that the from address remains as an account address, and the to address is a contract address. I have chosen a contract which is a famous smart contract, or a famous dApp known as CryptoKitties, right? I'll show you that in just a bit. And I have chosen a contract called CryptoKitties, the core contract of CryptoKitties, to which some amount of some kind of transaction has happened. Now, it may not be a ether transfer transaction. It could just be a call, right? So in a smart contract, there could be two types of transaction. One is you could be sending some ether, or you could just be reading some data. So this transaction looks like it is just, reading something from the CryptoKitties smart contract, right? So that's a type of transaction that is happening on this Ethereum blockchain. So we have covered all the three types of transaction. I've shown you some examples. You can also explore on the browser to look at more examples of calling a contract, sending some ethers to a contract, transferring. Of course, you will find hundreds, thousands, and billions of transactions on Etherscan, which are just, one externally owned account to another externally owned account transactions. Well, now let's explore the mystery of this element called gas. Okay, I will explain about gas from a developer perspective. You can also read up more about why gas price is fluctuating more, and what is happening around the behind the economics of gas price itself, right? But what is gas, right? What is gas price that you see in every transaction? So every transaction that happens on the Ethereum network incurs a transaction fee, right? Because there is some work that is happening in the background in order for the transaction to happen, to take place, right? And that transaction fee is calculated in units called gas. Now, what is gas? It is actually the amount of ether that we are paying for the transaction to go through, right? So that is the gas price or the gas fees, right? So we set a gas limit, right, beyond which we cannot pay for that particular transaction. So if we cannot pay beyond that, then that transaction doesn't take place whenever we set a gas limit, right? So why do we use gas, right? And why not directly pay through Ether? Because Ether, as we all know, is such a volatile cryptocurrency. In fact, all of these cryptocurrencies that are trading heavily are very volatile in nature, and the value of Ether keeps changing as per the market state. Whereas the gas price that is calculated for a particular contract is fixed based on the bytecode or the instructions that make up that contract. So, if you are familiar with the basics of computer programming, or rather, how a program gets compiled and then how a bytecode of a program is generated, right? Bytecode is something that is easily understandable by the machine, right? So, it's more of a machine language code, our program that we write in in plain English, or rather in any particular language, needs to be understood by the machine, right? So it is converted to a byte code so that the machine can understand that particular program. And the byte code, if you see, is in the form of instructions for the machine, like and these instructions are very basic set of instructions, like add two numbers or subtract numbers from any two registers, right? Move numbers from one register to another, or rotate numbers that is present in a particular register, etc. So you can read up more on opcodes, right? What are opcodes? But these gas prices are associated with opcodes. For each opcode, there is a fixed gas price. So for your contract, when you calculate the gas price comes as a fixed price, right? And that's why we have another entity, that is gas, using which we calculate as to how much effort is required to deploy a particular smart contract, or to interact with some smart contracts, how much transaction fee should actually be paid, right? Now you might see the symbol GWEI or GWEI, right? That is nothing but way, that is WEI, is the smallest unit of ether, right? Wherein 1 into 10 to the power 18 way represents 1 ether. So in order to calculate the gas price, we sometimes represent it in the form of GWEI, right? But if you want to see the gas price as for each and every opcode, you will be able to find it on the internet easily. If you just Google like gas price opcode kind of table, you will be easily able to get that. You can even get a matching GUI to opcode conversion. Like for this opcode, how much price do you pay? So you can write your smart contract accordingly, right? If you write too many loops, right, the gas price of your smart contract would shoot up. If you perform too many complicated operations like encryption or decryption, any heavy operations, then your gas price of your contract will shoot up. So you can write your smart contract accordingly so that you have to face less and less gas price while deploying the smart contract on the mainnet.
Thank you, and looking forward to seeing you in the next session.